Acceleration. What is acceleration? Rate of,
Rate of change of velocity.
yeah, exactly. Rate of change in velocity. Or you can say change in velocity per unit time.
For unit.
It's fine. So
Yes, fine.
means acceleration is equal to change in velocity divided by time interval. So as we know, acceleration is denoted by A, change of velocity is denoted by del V, and time is del T. It's fine. Now
Yes, fine.
we know that the del V means change in velocity. So means there are two velocities. One is known as U, which is the initial velocity, and other one is V, which is the final velocity. That's why del V will be equal to V minus U. It's fine. So therefore,
Yes, fine.
the acceleration A will be equal to V minus U divided by T,
Yeah, we must you do it.
or we can write AT is equal to V minus U, or we can write V is equal to U plus AT. And this is the first
U plus
equation.
A.
Yeah, this is the first equation of motion. Okay. There are
Yes.
Sweat equations which we are using in the equations of motion. This one is the first equation. Another equation is S is equal to ut plus half at square. Another equation is v square minus u square is equal to 2as. And another equation is average velocity is equal to v plus u divided by 2. These are the Sweat equations, okay? Which is using for the equations of motions.
Yeah, okay.
I'm going to
Mm-hmm.
dis I'm going to discuss in detail, okay, these Sweat equations. You just note it, okay? Yeah.
Okay.
Okay, now coming back to acceleration. Acceleration
Mm-hmm.
is
Acceleration. Yeah.
vector quantity
What's the quantity?
and its unit is meter per second square.
Mm-hmm.
Okay. Now, the types of acceleration. The types of acceleration. First one is average acceleration. Means that total change in
Total change,
velocity
velocity,
and total time.
total time.
That is known as and total time. That is known as average acceleration. It's fine.
Is fine.
Similarly, the second one is uniform acceleration. Uniform acceleration, or we can say
acceleration.
constant acceleration. This is known as constant acceleration. So it means no change in magnitude as well as direction of acceleration. Okay. There is another acceleration
Okay.
which is known as instantaneous acceleration. Instantaneous acceleration. Okay.
Yeah. Okay.
The acceleration for short time interval. Short time interval. That is known as instantaneous acceleration. How much short? That your time is approaches toward the zero. That time is approximately near to zero. Okay. Approximately.
Instantaneous acceleration.
Sorry.
Instantaneous acceleration as well.
Instantaneous acceleration. Yeah. Instantaneous acceleration is that acceleration in which the acceleration of for the acceleration the time is very short. So for that instant, it is acceleration which is noted for that point where the time is very short. Okay. That is known as instantaneous acceleration.
Your
Yeah.
voice is lagging.
That's a problem of net on your side. That's a problem of net on your side, Alian. Yeah. Hello.
Yeah, I can hear you.
Now it's fine.
Yes, sir.
Okay. Instantaneous acceleration is there, the acceleration for the short time interval. Okay. Where the time is very small. Okay. So for that small time, which we have find the acceleration that is known as instantaneous acceleration. That's fine.
That's fine.
Okay. Have you noted that?
Yes, sir.
Okay. There is another type of acceleration which is known as deceleration or retardation. So when the change in velocity decreases with time interval. It's fine. So that
Yes, sir.
acceleration that is called deceleration or retardation. It's fine. Yeah.
It's fine.
So let's check the retardation spelling. Retardation. I think this is the spelling. Can you check the spelling? Okay. Kindly check the spellings of retardation.
Regression.
Yeah, retardation.
Re-
Okay, let me correct the spelling.
retardation.
Yeah, let me correct the spelling.
Wait, retardation.
Yeah, that's the spelling. Retardation. Now we are going to discuss the graphs, okay? Graphs. It's fine.
That's fine.
So first of all, let's Let me from the start, we are going to discuss the graphs. So first of all, we are going to discuss the graph between distance and time. It's fine?
Yes, fine.
Okay. So in this graph, on the x-axis, I will take time. On the y-axis, I will take distance. This is the rest graph, okay? So this is a rest graph means your object is at the position and it is at rest, okay? It's not changing its position.
Yeah.
It's fine? Okay, so this is a
It's a
rest
time
graph.
graph, right?
Yeah. Sorry?
Yeah, for the distance time graph, this line is at rest, right? For
Yeah,
the distance time graph.
exactly. So it means that person is at rest, okay? Yeah. This is the first graph. Now the second graph. Now this is the graph. This graph is for the constant speed. So constant speed means acceleration is zero. It's fine. Constant
That's
speed
fine.
means acceleration is zero. Now the
Acceleration.
third graph, this is my third graph.
Yeah.
This is variable speed, variable speed graph with increasing gradient,
Hmm.
with increasing gradient. It's fine.
Variable speed increasing rate.
Yeah. Okay. Another graph. This is the distance time graph. And this is my fourth graph, like that. Okay.
Constant.
This is again variable speed, but this time decreasing gradient. This is decreasing gradient. It's fine?
It's fine. It's fine.
Yeah. The next is the this graph is again for this graph is variable speed, but negative gradient.
Negative rate.
And the negative gradient is decreases, okay? Not increases, decreases. That is the fifth graph. Now the next graph, this is the next graph. Again, this is the variable speed graph, but this time again negative gradient. but increasing. Okay, negative gradient but increasing. It's fine now.
Yes, sir.
So these are the graphs of distance time graphs. Okay, these are the 6 distance time graphs. Yeah, pattern graph. Okay, we will take the problems, but these are the pattern graph, 6 pattern graphs. Okay, yeah, 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 yeah.
Yes, yes, sir, I'm here.
Okay, have you
Negative
noted that?
increase, decrease,
Yeah, have you noted that?
indeed, sir. Yes,
Okay,
sir.
okay. Next, we are going to discuss the graphs of speed time graph or velocity time graphs. Okay, speed time graph. This is the first graph between speed time graph. This is a constant speed and acceleration is zero in this graph. Yeah, it's fine.
Yes, sir.
So another graph. So now this graph is basically variable speed, but acceleration is constant. But acceleration is constant. Yeah. So there is another graph. So this one is graph in which we says velocity, variable velocity, variable speed, but acceleration is changing. Okay. Or you can say acceleration increasing, increasing.
Yeah.
Okay. Because the gradient is increasing. And this is positive acceleration.
Yes.
Okay. Not negative. This is positive acceleration. Another graph. So this is another graph. This will be like that. This is my fourth graph in which again variable speed. So acceleration.
Sir,
Yeah.